from Australia. Do my magical fix that for you. Alright, this is going to be a rushed talk. That's not it. I'll start the timer. So I've got 10 minutes. I'm going to try and cover just one of the fun things we do at work, or what I think is fun anyway. We use Debian for our systems. We run them on ARM processors. They are where's my mouse? Not that one. We have a small little CPU. It's running 400 megahertz. Got 128 mega RAM. It's pretty pathetic, and it sucks to compile code on. We are running Debian 8 on it, and we need to be able to build packages, build tools for it to deploy on the customer units. So you can either cross-compile a tool, you can build a GCC compile chain, cross-compile chain, and then compile your apps. But if you're building a Debian package, there's a lot of other scripts and tools that are used to build that package, and you then need to cross-compile them or have x86 equivalents that will produce the right output. It sucks. There was a big push in Debian called Embeddian to try and make the source code packages in Debian compatible with cross-compiling, and that fell on its ass, and here we are. So we are using Docker and QEMU, which is the emulation, ARM instruction emulation built into the kernel. When you run an ARM binary on an Intel platform, the kernel goes, hey, there's an ARM binary, and hands it off to QEMU, which translates the instructions and executes them. Who would have thought that would work seamlessly, but it does. Alright, so QEMU. Everyone know what this is? Everyone's played with this. Everyone probably has heard of Docker, so I'm not really going to talk much about Docker. I didn't even put in a new file about it. And there we go. Yes, no. Let's make it bigger for you guys. So I prepared something a little bit earlier, as in half an hour ago. I'm going to do a build. I think I'm going to do a build on my work machine. I'm going to basically take a Debian package that I like and I want, and I'm going to compile it on my Intel machine and build an Intel an x86 Debian package. This is what you do. You download the source of the package from Debian. You just type out get source. And I'm doing htop, am I? You tell the Debian package manager to grab all the build dependencies for it, and I've already done it, so it's probably going to come back and say nothing. But the first time around this demo, it downloaded 3 packages, installed them, and off we went. And now I'm going to build it. Time in, so we know how long it takes. D package build, yada yada yada. This is all just normal Debian package building crap. Take note of the time when it finishes, because I didn't. 16 seconds. Alright, we're running an Intel AMD 64 kernel. That was too quick. I wish I could pause this. Can you pause it? No. So we're running 64-bit. We've just built a 64-bit object for htop. It's compiled the Debian packages. There's a 64-bit .dev package there. And now I'm going to drop into an ARM Docker container that I've made. I've made a little Debian tarball, Debian root file system tarball, made a Docker image. I'm running it. You'll see, I'll show you the Docker command. This is just basically running Docker, and it's peaks, we're now running ARM, but it says it's an AMD 64. And this is a demo. I didn't get to make it nice. Luckily, I didn't do it live, otherwise it would have broken. So now I'm running inside a Docker container. I'm going to do the same Debian process of downloading the source package, downloading the dependencies, and then compiling it. Yeah, I screwed up. So I didn't have in my Debian Docker image, I didn't have the app sources set up. So I'm going to edit that quickly. Oh, good, it's off the top of the screen.
So did you have a whole copy of Debian inside the Docker container?
No, so I have a build script that I wrote that basically does a dev bootstrap, which is the Debian bootstrapping command, and does a two-stage Debian bootstrap. It installs the ARM packages into a shallow directory and then mounts it, hands it off to a Docker image and finishes off the rest of the Debian bootstrap. And I end up with a little image about 180 meg Docker image or a tarball. I also spit it out as a tarball. So it's pretty small. It's only got the bare essentials of Debian in it.
So
Yep.
is part of your build actually running 64-bit AMD?
So we build for multiple architectures. One of them is the ARM.
Well, I mean, you're targeting the ARM in your Docker container,
Right.
but is part of it Docker using the base kernel running on data
Yes.
processing?
So the kernel's running 64-bit, an Intel i7 64-bit, architecture, but everything inside the Docker container is ARM binaries. The package manager, LS, everything else is ARM. And when you run that inside Docker, QEMU catches it and translates it on the fly.
And so is there a really great tutorial on setting up QEMU to run natively on your on top of your Docker, or is it pain in the?
There's almost no setup at all.
So is that
You
your
have to-
second lightning talk?
Sorry?
Is that your second lightning talk?
I can expand this talk later if you want, but I've got, 2 minutes left. So you'll probably see me fail a couple of times. Now I'm going to try and build it again. I'm going to time it. And it's going to fail.
So to try to recap what I thought I heard, you're in an ARM container, so you think you're on ARM, so you can use all the ARM packages.
Yep.
Thank you.
And so you're telling this ARM container to build an ARM package, and it uses all the ARM tools in that container to do it.
And then you just export it over to your real ARM system.
And I get this Debian package out at the end, and I just copy that over to the real system and
Oh,
repackage install. And I'm done.
That's not much overhead.
no.
And it's not as fast as cross-compiling.
Of course,
It's slow either.
It failed.
Oh,
So my little Debian ARM Docker container, it was built on a different version than my desktop. So we're actually going to do it next. Is it? Come on. Hurry up. There we
you
go.
were thinking.
Probably eating dinner, trying to shovel it in before I come to this meeting. So you're getting all that crap from me trying to build this. But what else can I say? It works. Debian packages are easy to download, modify, rebuild, repackage, stick back in our app repository at work.
I guess if you could comment, sometimes groups talk about, instead of making your dev packages, what you did is you might have moved your whole application as a container over to the ARM. Did you guys think of that? Is that
Yeah,
some of the pluses and minuses?
We're looking at that. Our ARM processor is 32-bit
Okay.
and it's small, but we are interested in doing some sort of containerized layering system on that to make upgrades easier. But I'm hoping we'll move to a new 64-bit ARM processor soon and not have to worry about it. Yay! That's my time. I can continue if you want, but otherwise I think I'll jump out.
I got room in this.
So how much time did it end up taking, you know?
Wasn't still going when you left, like you come here.
No, it finished. I shut my laptop and left.
So we know it took 30 minutes.
All right. Any other questions?
So QEMU, that's running on the that's running on the main system, and it's your kernel is the one interpreting those ARM commands, right? Or is QEMU running inside the container itself?
So, yes. The kernel is detecting that the binary that you're handing to it is not Intel.
Yeah.
And says up and hands it off to, I believe, the user space QEMU static implementation. So the little embedded Debian Docker container with all the ARM binaries in it has an extra binary stuck into /user_lib, I think, called static QEMU ARM, and then that does the translation and hands it back to the kernel.
So what do you do to set up that automatic passing on? Because before when I used QEMU, it was I called QEMU and then pass a binary to it.
There's all you need to do is drop a static library into the right spot in your root file system, and it will then interpret it. So you can do that on a Docker container, or you can do it on your live system. If you've installed the QEMU tools, you can just run the ARM binary direct on your laptop. Are we building? We are. Okay, so we're building a different version of HTOP, but at the end of this, we'll actually show you HTOP running. How long did it take? 2 minutes 28 compared to what? 12 seconds, 16 seconds?
So I assume you're running the Linux on as the host and not running it virtualization. Did you have any problems with virtualization? I mean, did
No, we've got build servers running VMware build server guests, and then they run Docker containers within them. You just had to have a 64-bit processor. So there's there's HTOP running inside a Docker container, thinking it's ARM. And you can see there's a QEMU ARM static binary doing the interpretation for bash and stuff like that. And it can only see certain processes because it's not a privileged container.
So,
Quits out. I don't know, it was probably too quick, but I did a file on the HTOP binary to show you that it's actually ARM. It's right there. This should be the end of the presentation. So it's an ARM HTOP. I did file HTOP. It's an ARM binary, and I just ran it directly. I didn't show you, but it hoops out the Debian package as well. So, done. More than 10 minutes. Sorry. If I trim it down and get rid of the screw ups. All right. Next.
So now that you've seen how to do packaging, we'll now demonstrate how not to do packaging. So a little context. I work in a financial institution, and those sorts of institutions are famously risk averse. And so we have, let's say, an older technology stack, and trying to move that forward, but getting the approvals and moving it through the various hoops and whatnot we need to get there moves at somewhat of a glacial pace. So what I really wanted, I've got a lot of, I've got suites of scripts and software that we need to use and install. And of course, the right way of doing this would be to create a Debian package or run through Ansible Puppet or something like that. And those things we're getting the gears moving on, but we're not quite there yet. And in the meantime, I still need to install the software on our systems, and preferably in such a way that you're not running through a Word document full of instructions on then edit this file into. So what I really would like is something that would just install itself. It doesn't require any particular package management, doesn't require any particular this, that, or the other until I can get a good standard in place. I just want something that will take care of itself. Preferably something that can be installed in a test or in the live directory. And so I cooked something like that up. So as I said, the reasons for this are basically that we've got a lot of red tape in place that to put some certain things in place. So for example, if I wanted to get, there's a package called FPM, which stands for Effing Package Management, which is a great piece of software, by the way, to turn any package into any other package. You can turn Debian into RPM, RPM into Tarball, Tarball into Debian, etc., etc., and so on. What I really like about it is their main, one of their main philosophies is if it is difficult to make a package with FPM, that's a bug in FPM. If it's hard to understand the documentation of FPM, it's a bug in FPM. They're basically saying, we're here to make this easy. But at any rate, so getting external software into the financial institution is a lot more difficult sell. It's a lot more difficult sell than, hey, I wrote this software for us, let's use it. That requires a lot less approval. So that's the motivation for why I wrote it. I also wanted something that was not going to require a bunch of rewriting once I did get something battle hardened in place, something that would be that I can tear up and push out. So this is essentially the structure of the self-installer. It's basically a shell script. It's really 5 sections. You've got a bit of a preamble, which just sets up some file locations. And you've got a base64 encoded chunk, which is the actual installation script. Another little bit of code to make sure that, the extraction of the installer went well. Another big chunk of base64 is actually the gzip tarball that's the actual software itself. And then something that checks to make sure the extraction of that went well, and then runs the actual installer after it's done. So I built this using Make, and all I do is essentially I take the software out of the Git repository. I build a temporary directory structure that mirrors what it's eventually going to look like, and then I tar that up and use it and throw it into a temporary packaging directory. Then I take some glue code, paste it together with base64 encoding between, and make that into a shell script. Obviously, I'm going to show it here in just a second, but that's essentially what goes on. All right, so let's see if I can remember where that desktop went. Not there. Hey, there we are. That's not a little bit better. More. Another one. We good? Good. Okay. All right. So this is essentially the extractor code. So these are the pieces of the shell script. There's actually 3 shell scripts in the split bin window. So the top one is the preamble. Turn it sideways so I can see. And so up here, they've got some pieces. These are filled in at build time with by the makefile, where the installer route goes, etc. And then what we're doing here is this is the beginning of the extraction. So it's a here dock, and you basically just cap the install the base 64 installer, throw it through base 64 minus B, and write it back to the installation executable. The middle is just did that work? Was I able to decode it? And if so, then do the exact same thing with the actual software package itself. So it's the tail here. Again, check it, make sure that it's okay, and if so, send it executable, and do the installation. So it's very kind of a thin wrapper around a couple of different pieces. So the actual installation script itself basically just takes it does a little bit of checking on its own. If it's minus live, it puts it into wherever it actually belongs. Otherwise, it's going to throw it into end of our temp, so just a temporary directory that will mirror the final location. Basically, goes through a couple of things to make sure that everything is in place. This is all, by the way, please just think curiously. This is all up on GitHub. The link is on the site as well as listed at the end of this talk. So you don't have to write anything down. Not that you should, but anyway. So at any rate, when it's doing the install, basically it goes through the standard directories, minutes, lib, whatnot, and just does an rsync so that way it can peacefully coexist with other packages that might be set up this way. So if I've got two packages that are working this way, they can rsync into the same directory, and as long as two of them don't think they own the same file, it's fine. And then, as an example, if there's a log directory, we can go ahead and create that at install time. And then I've also got a vendor directory, which for this purpose is very trivial, but in our case, we actually have a few libraries that we have to bring in and create on the fly. And so if there's a vendor directory, go in, make whatever it is in there, and it gets made on the installation host so that it's it takes into account the environment. All right, so. All right, so the make file. Bunch of commentary, but what basically happens. I'm going to scroll down a little bit, obviously. This is the main portion of it right here. You have the extractor, put it into the final package. Here's where we substitute the package name and the payload name into the scripts we're going to use, and then put in the middle. Put in base 64 encode the installer. Put that into the sub extractor. Put the extractor middle in. Basically, just pop it all together, and then spawn it to execute. And so the rest of it's just how to put the stuff together. Now, in this case, right here, package payload down at the bottom. Middle now. Package payload is just right now. It's a straight copy of source into the destination. There are a few other steps that we use on our side, but again, this is a demo. And so, but it essentially is the idea is you're creating what your code should basically look like at install time in this temporary. All right. All right, so here I am in bar 10. Actually, let's do a build. So this is where it's creating it. Pretty simple, pretty basic, and it creates the script installer awesome utilities, which is the built-in version of what you were just saying. So there's there's an installer right there, basically coded. There's the package and a lot of it until it gets sent again. And then, right. So that's the structure of it. All right, so I'm in our temp. You can see there's no directory there right now. So let's install. All right, so this is it flew through the rsyncs. It is creating, as I said, the temporary directory here is under our temp. This is just going through the make of a JSON library. It's one of the ones we use, but it's really, I don't use it for demo. And you can see there's a test our stuff directly. All right. So what you can see here is I've got do something. Right. Is basically we've got our code structured so that it's relocatable, so that it finds out where it's running from, so that it'll pull the libraries from the same root. And so it actually pulls in the first lib, which will echo out what it's where it's running from. In this case, largely just our stuff. And then so you can see there's stuff in all directories. So, and as well as manifest to tell us where the package came from and what the revision was. All right, so now, so I'm happy with that. I want to do it live. And I didn't show you ahead of time, but the destination directory was empty.
So what's the advantage of this over just unpacking the table?
Because one thing we've got to install additional, like vendor libraries, we've got to install additional libraries as dependencies. For another thing, I want something that does as much of it. There's a few extra steps that go into it that I'm not showing here. I want to limit as much as possible to one step. So basically, this goes up onto our repository server. So if somebody needs to install this on one of our servers, they pull it down, they run it, it's done. And there's no instructions of, okay, CD into this directory and do this. You know. Right, so this is all under user local R stuff. So right, so as you can see, now it's coming out of user local R stuff. And that one's just cute. So anyway, that's what it is. Questions, comments, shrieks of terror.
So do you support like a heterogeneous environment where you have like some RPM-based systems, some Debian-based?
Yeah, we've got multiple versions of Red Hat, but it's mostly Red Hat system. But Red Hat, AIX, Solaris, I believe we've got a couple of Unix systems, Ubuntu running around. Yeah.
Can you create a heap package, and can you serve that from a server and get it installed like a traditional Debian distro could do installs?
So most of our install base is RPM based, so it's mostly RHEL. Questions still stand, I would imagine. So we do have some of that stuff in the works. We don't have the infrastructure yet to support a yum install.
And what about updating? Are you a manual package update when you re-release code? Or, because I could see this, you get into the target package like an RPM, and then they just run updates on their system at a routine basis, and it picks up the new updates.
Yeah. That's kind of the goal where we eventually want to go. Right now, it's manual. And to be fair, this package runs on only on a handful of servers, on like administrative servers, not like the vast majority. So that's also why a certain amount of manual work isn't terrible. But yeah, the goal is to like have something that will integrate with Puppet. It's our main deployment system, so that this goes away. But one of the things that I wanted in this is, although there's some code surrounding it, really you've got a tarball and an installer at the base, right? So I mean, it's kind of a delivery mechanism just for that. And once the delivery mechanism goes away, the rest of it doesn't necessarily need to change all that much. So. All right, that's it. As I said, there's a link to the GitHub repo on the site. So if you just go to TriLUG Meeting Nov, you'll be on.
Do we know who's next?
We do not.
Absolutely. Toys, no props. I have no slides, only props and my notes. And I've also never given this presentation before, although I talk about this stuff almost every day. And so I'm just going to kind of launch into it, and we'll see how it goes.
Hopefully non-disaster.
Non-disaster. Well, I won't have an AV disaster. We know that because, and I had one of those today because anybody live in North Raleigh? Time Warner Cable? It died about 1 o'clock today, and that's when my conference call started. That was not fun. I can tell you. There's my last problem. Okay. So
ruler you just put up there?
I did. I just put a ruler out there, and that's the culmination of everything when we get done with this. So what is my talk about? Well, my wife asked me, "See, what is the name of your talk?" I said, "Well, I can't remember. What did I call it? Rapidly changing storage formats." Now you might say, "Well, this is Linux, the Linux user group. This has nothing to do with Linux." Well, you've got to install Linux on something. So I kind of work at the base of all this stuff, and I am a Linux guy, so I like working with Linux a lot. But I do work for a storage company, and so I get to see a lot of the stuff that's happening in the storage world. So I just thought I would tell you some things that I think are happening, and where we're coming from, and maybe where we're going. So if everybody remember this, right? This is the 5.5-inch format. It sort of started, back in the 80s, I think. And this used to be a hard drive format size. We started off with that. We actually came down from 8-inch into this guy, and they used to be bigger. You may remember that. Yeah, the full height. This is what they call the half height. I don't have any of those around anymore. Not the disk drives.
I used to have a TrueGuard 8-inch that was this wide and about this tall, and it was this long.
And it dimmed power when you power it spun it up too.
You bet. There was big fans and big power capacitors in the back of it.
Absolutely, absolutely. So anyway, this was the original floppy drive form factor. If you may remember that, there was a 5.5-inch form factor for floppies and all that. So the only thing we're left with this today is really for optical drives and towers and some servers. So that's what this is. This is a DVD drive. So you'll see this form factor still around. So okay, that was one of them. The other one is the next one that we came through was the 3.5-inch. So you may remember, you see this one a lot. And again, this has been a hard drive form factor. Pretty much the only thing I can think of came in this. There was also, I guess, the 3.5-inch floppy drives also used this same form factor in a lot of servers. So you saw this around. This particular one is SCSI. That's a parallel SCSI. I thought I had another one here. Oh yeah, that one is that's parallel ATA. So lots of different interfaces. I'm not talking about interfaces. I'm just talking about form factors. But lots of different sizes there. So you've seen a lot of these different things. So the 3.5 inch started to fade a little bit in the 2000s, in the early 2000s, in favor of this guy, the 2.5 inch. Because why did we do the 2.5 inch? Anybody remember? 2 reasons. Higher density. That's exactly right. I could get 24 of them in a 2U rack space, and I was trying to get as many spindles as I could get to get performance. And so that's where we kind of came from with the 2.5 inch. We had these fun things like little sticky float, as you pop them into servers and stuff. So that was really important. But we also use these we also use these in laptops. This was the laptop form factor that sort of came flowing out of that. Now, I've got one more. Oh yeah, here's my other friend. So then we came along and started building SSDs in the same form factor. Right? So this is the 2.5 inch form factor for SSDs. Now, this is a really particularly horrible form factor for SSDs. Why is that?
Because if you open it up, it's mostly empty space inside.
Actually, in some cases that's true, but in this case it's not. This is actually a 3.84 terabyte SSD. So Chris knows about all these because he's taken them apart too many times.
There's 3 circuit boards with a rigid flex folded over each other.
And that one in the middle gets really hard to cool. So that's what makes this a really nasty form factor for. So why do we use this? Well, because of this, right? It's a stupid reason for doing it, but that's why we do it, right? And we also use, this is a SAS drive, so I plug it in, I use the SAS protocols. That stinks. That's not a really smart thing to do. So, but anyway, that's where we come from. Then we had this little guy. Did we ever see one of these?
Micro drive?
No, this is a 1.8 inch SSD. This is a SATA. Did we ever build a SAS?
Yes.
Isn't that?
Yes, we did for a very short time.
I never saw one, but I always saw SAS.
It actually got used in System Z.
Ah, okay, could be. You're probably right. So anyway, this was the 1.8 inch. Now, I want to come back to this. I will come back to this in a minute because you're going to see a sort of a resurgence of this guy here in a little bit. We also had the 1 inch hard drive. Everybody see those?
Yes.
Right? Now that one was kind of very short lived. Didn't hang around for a long time. What killed that? SD cards, compact flash. That's what killed that because that was used in a lot of really small video cameras. Let's see, I think the original iPod had that thing in it? Yeah. So anyway,
Stop building once they burn out.
yeah, that was an interesting form factor there. So that's kind of, and then I'll show my, a lot of you guys know I used to work for Fusion IO when we existed, and then we had the PCIe form factor. We could get very high data rates because we're actually connected directly to the system bus. The DMA directly into memory. Very nice, not real flexible. I had to open the case to put it in and everything. So there were some drawbacks to doing this, but that was another form factor. Well, this is not little heat, yes sir, absolutely. And sometimes you put these things in places where it gets pretty hot and you don't get a lot of cool air. So that's a little bit of a problem with that form factor. But anyway, that's kind of where we've been. Oh, there was one other one that I sort of ran across this one today. I'd kind of forgotten about it. MSATA, do you remember that thing? I don't have one here. I wish I had a picture of one. But MSATA was used on a lot of laptops and tablets and things like that. That one is fading pretty fast. I think we're on the last version of that ourselves. So MSATA is kind of going away. There's another form factor called M.2. I so hoped that I would have one to show you, but I work on the enterprise side of the world, and we don't have a lot of those things. And I was trying to obtain one this week, and I was unsuccessful. But unfortunately, MSATA is still hanging around very nicely in the client world. We're starting to use it a little bit in the MSATA in there.
It's
So M.2 is used a lot in the client world. A lot of laptops use that today. There's various links of M.2. So you'll see 60 millimeter, 80 millimeter. I think there's another one too. So there's several of those links that you can use. But very strong in the client world. It's getting used a little bit in enterprise, but I have a feeling that not going to hang around for that long. We'll see what happens there. So where are we headed? So let's talk about that for a second. So this guy, the 3.5 inch, is here to stay, I think. I don't believe you're going to see that change at all because the capacity hard drives, we're now up to 14 terabytes in capacity hard drives. These things are going to continue out. I know our roadmap is actually showing things as big as 20 terabytes in the 3.5 inch form factor. So this form factor will stick around. You're going to see this used for hard drives for here on out. They're big, they're slow, they do what they do. I mean, if you've got a lot of data that you need to spin off, it's a great place to stay. So that's the 3.5 inch world. The 2.5 inch, this guy here, again, that guy I think will stick around for a long time. We're using it for SAS, we're using it for SATA, we're also using it for NVMe. So if you're familiar with NVMe drives, again, that's more closely related to this because I'm actually using PCIe to actually plug these in the front of a server. Or in laptops now too. There's a lot of NVMe in laptops as well using that M.2 form factor that we talked about before. So we've got several things like this happening in this world. I think this form factor sticks around for a long time, but it stinks, as we mentioned before. It's not a good form factor for flash, and you're going to see this thing, the hard drive form factor of 2.5, absolutely fade away. This will not stick around much longer because the 2.5 inch hard drive is not sticking around. This is a 10K hard drive. We also make 15K hard drives. We can't make them any faster. Can't not build a faster hard drive because of physics. You can't spin it any more than what you're spinning it today. And so I can take the slowest piece of flash that I can ever come up with, and the slowest piece of flash that I can show you, this thing will be a rounding error in its performance compared to this. It's so if you're going to do performance, you're going to use some kind of flash. That's the right way to do it. So anyway, we'll see how that all goes. But let's see. I'm going to go ahead and sort of bring this all together. So that's where I get to my friend the ruler here. So this is what's going to happen. There's my prediction section of the talk. There is a new form factor that's now on the horizon. We will be building some products based on this probably next year. And so you're going to see this. There's the new form factor. It's called EDSFF. And that's what is it called? Enterprise Data Center Small Form Factor is what that's called. EDSFF. And there's two of them.
Wait, center spelled with an S?
Data center is considered one word.
Yeah, data center, one word. Yes, I'm sorry. EDSFF. So EDSFF has there's two camps in that world. One is EDSFF long, and that's about 31 centimeters, and that's just about the size of a ruler. And they look just about like a ruler. The thing that's nice about this form factor, it's about the same thickness as this guy, has a very similar connector as this guy, and so you can imagine something that looks about like that thick but is this long. It's a great form factor for flash because I keep everything on one board. I don't have to worry about doing that triple fold over Chris was talking about and trying to keep that middle board cool because I can now keep the airflow on both sides of it. So that's the thing you're going to be seeing probably in next year is EDSFF. There's also another version of EDSFF, and it's EDSFF short. And that guy is about this long, okay? So it's the short version. It's about 11 centimeters long. And you're seeing the server guys kind of get behind this one more, but the storage guys like this one because I can stick a bunch of them in. You could stick as many as 42 of these in a one-use server, in a one-use rack space. So, a lot. As we move into 3D NAND and things like that, you will see sizes as big as 15 to 30 terabytes. And
Look at what you can put in a micro SD card now.
yeah, that's right. I mean, you get a lot there. So imagine I could take 30 terabytes each of these and stick 42 of them. Now, the only problem I've got right now is since these are all NVMe, and again, that's basically the same protocol as this guy, right? This thing works off PCIe. I can't, my current server world and the current, the way things work inside the systems, I can't get enough PCIe lanes up to the front of these machines to stick 42 of them in. I got plenty of space. I cannot create enough PCIe lanes to actually stick these things in. So I'm going to suspect that you're going to see the initial boxes of these maybe have 28 to 30, so you'll have enough PCIe lanes. And then as the architectures change, these things can get more and more dense, and we can just go really wild. So that's my prediction. So you'll see this folding out over time. So what will we be left with? Well, we'll be left with this for a while because SAS is going to stay on this for a long time. As long as we're using SAS, we'll stay on this. You're going to see this guy. You'll see the M.2, especially in the client world. That will really begin to take over that world completely. And then one of the two EDSFF versions, either the ruler, the long version, or the short version, which is about the 11 centimeter version. So we'll see how it all plays out. Yes, sir.
As they get into larger storages, though, will you start to do what they did the old day with the mainframes and put heat pipes in or something?
We're hoping that we won't have to do that because we'll actually, since they'll stay pretty thin like this.
The surface area to volume is really, really good on
Yeah.
compared to the SAS drive.
Yeah.
And that SAS drive can have 9 to
It's really
14
expensive.
watts.
It's really expensive to cool it.
So yeah, any number of things could happen in that part.
Also, when they originally came out with SSDs, they kept talking about if you use them too much, they wear out.
Yes, sir.
How's that?
It is like, for the most part, it's the biggest non-problem in the world. But mostly based on the idea, people just don't write as much as they think they write. That's what we learned. I mean, when I was working for Fusion, that's what we found. Basically, one of the reasons Fusion doesn't exist today. They were expecting folks to wear these things out, and they didn't. And they kept reusing it. They got done after 3 years, or like a 4-year server rotation. They get done, they query the card, and it says, "Oh, I've got 93% of my endurance left." And they would reuse it. So that's the way it worked. And for the most part, endurance has been a non-problem for the most part. Okay, thanks, folks. Appreciate it.
So one question, I'm not as familiar with the newer M formats of drives.
Yes, sir.
I heard a story that M SATA was electrically the same as SATA, but just had a different connector.
That is what I understand as well.
How much about what exactly M.2 is and how that differs from?
M.2 is a form factor. It's not an interface. You can actually build NVMe or SATA. Those are the two common ones in the M.2 form factor. So it's really a style more than a connector than an interface.
Is there anything coming after Flash like the Intel update and stuff?
Absolutely. There's all kinds of things going to happen. So stay tuned. Maybe we'll do when we do lightning talks next year sometime. We'll talk about that. I'll know more then. Thanks, Doug.
I'm not. Supposedly, basically, in matter of fact, you have to have a PCIe lane for it.
All right, hi everyone. My name's Barry. You might remember me. I used to be a pretty active TriLUG regular and stopped showing up when it became too much of a drive. So what I'm going to try to do in the next 5 minutes or so is give you a brief introduction to a software project called Mastodon, which I'm personally very interested in. And what it is, in sort of the shortest possible expression, is it's an open source, federated microblogging platform that implements the GNU social protocol. So microblogging, if you're not familiar with the term, is a form of online short-form writing, often constrained by a certain number of characters. The most popular microblogging platform out there is a site called Twitter, which you may have heard of because they make an awful lot of money and noise for what they provide to the world.
They don't actually make very much money.
That's true.
Okay, well, they make a lot of noise. But either way, most people know about them, as evidenced by that. And while this talk doesn't have time to go into why people might want to do microblogging, I'm going to be talking about an open source platform that is attempting to do some really cool technical things compared to what Twitter does. So Mastodon on its surface looks an awful lot like Twitter if you've ever used it. You have this idea of a feed, right? You subscribe to authors who are posting content that you care about, which you then see in a stream. There is one-on-one and one-to-many interactions, which appear in your notifications tab. And then you have this thing over here called the local timeline. Now, in a world like Twitter, where there are a gabillion users, the local timeline would be something that would make you dizzy if you tried to watch it as it populated. But what Mastodon does, which I think is really cool, is this idea of federation. Okay, so there's two ideas of a timeline. You have a local timeline for the instance that you're in, and you have a federated timeline that collects data from a large number of instances. So the first thing that most people who are coming here will figure out is like, where is Mastodon? How do I join Mastodon? And you don't join that. You join an instance of it, which may be something that's regionally interesting, such as the North Carolina or a Canada instance. It may be based on language. Maybe you're looking for the local French-speaking instance, or it may be built around technology, such as a Linux user's instance, which makes these instances very akin to things like IRC channels almost, where the local timeline that you're logged into will not be something that's overwhelming, but will already be highly relevant based on which instance you happen to join. Where it gets really interesting is the idea of federation. So let's say we created two instances, one for TriLUG and one for my alma mater, the NC State Linux Users Group. Let's say we have an instance for each of these that contain members in each organization. If I'm over here in TriLUG and I'm logged in, I can see all of the TriLUG posts. However, if any member in the TriLUG instance follows any member of the NCSU LUG instance, what will happen is the TriLUG instance will subscribe to all posts coming from NCSU LUG. So it creates this relationship between the two instances when one person follows it, which means that me performing that action of following someone in another instance allows anybody looking at the federated timeline in TriLUG to see posts both within their instance, within the NCSU LUG instance, and any other group that happens to be being followed. And this extends to things like searchability. So, for example, something that happened out of the whole Twitter world with the idea of the hashtag, a glyph denoted string of interest that could be searched easily to find people who are talking about topics you care about. That's one thing you can do, right? You can search for one of those. It will look through everything that the server you're on is subscribed to and allow you to follow people on instances that you may be separated from multiple degrees of separation. So, the other thing that's super cool about it is it's open source. The source code license of the AGPL, I did not actually take the effort to find out which language it's written in, but I'm sure I would find it out by clicking on a folder like lib or bin or app. And which means that in addition to joining an instance that already exists, you can start one of your own for a community that you care about. or if you want to be particularly geek cred seeking, you could create an instance for you and yourself alone, and an instance of one that can follow any of them out there and fully control your activity in the space. Because the one advantage that comes with open source applications like these is that it provides an alternative to the proprietary walled gardens that most of us associate with major social media companies that exist in the world, where we don't actually have control of the content we post. We are kind of at the mercy of them to introduce whatever features are going to allow them to monetize our existence the best. So, I have created an account on the flagship instance before they shut down new signups for increasing server load. But if this is something that does appeal to you as someone who may want to write short form writing for a very small but excitable audience, this might be for you. So if this does interest you, check out Join Mastodon. It explains the technology. It provides a searchable list of instances to join. And if you do join, you can find me by looking for my handle at my instance of residence. So, are there any questions?
So did you say, like, if you were following TriLUG?
Yeah.
And somebody else follows NCSULUG, now everybody following TriLUG will see NCSULUG also?
Yeah, so right here on the local timeline, there's another version of the timeline called the federated timeline.
Okay.
Basically what will happen is anything from an outside server that is created through this network of relationships will appear on that federated timeline. So as long as there's a mutual following relationship, people in both instances will see the posts of both instances.
Is there any policing mechanisms for things like, let's say I was in TriLUG and somebody just wants to cause trouble and start following WinLUG?
Sure.
Lug, whatever.
So when it comes to the idea of policing, which is really interesting because it's a much smaller environment, there's multiple levels. So, for example, let's say that maybe there are people who legitimately care about WinLUG. Then, if that's something you don't care about, you can actually block all posts from the WinLUG instance from ever appearing in your personal feed. So you can actually block anything from a server. There is a very large Japanese contingent in Mastodon who I'm sure are very creative, but I can't understand what they're saying. So I make an effort to filter out the language that I don't speak, so that way my federated timeline is not so cluttered. At the same time, let's say there actually is, like, virus lug causing real trouble, the administrator can block an entire instance. That way it doesn't start spamming their space.
So two people having a fight, they can police themselves and go in a corner and fight. Nobody else cares.
That's the idea.
Cool.
Go ahead.
So when these instances follow each other, is it transitive? Like if TriLUG follows NCSULUG and NCSULUG follows someone else, will TriLUG get someone else too?
No. No, one use, because what happens is each instance, what happens when one user on the instance creates that following relationship, that causes that direct subscription. So it's not transitive.
How easy is it to serve Mastodon? I wanted a new group.
I have not actually tried that yet because I'm unfortunately too busy. It's something I do want to do because I'd love to have my own domain. Supposedly it's on a Docker container, and I've on a Docker container before, so if you have that level of personal server administration, I can't imagine it would be too many steps separated from serving something like a web application.
I would assume that the hard part of that would be getting people to join.
Well, maybe you don't want anyone to join. Maybe you just want your own space.
Where you are.
I already have that without it.
Is that the official plan?
Yeah, it's all room with nobody in it.
This is the website.
Okay.
So this is the website version. I'm not familiar with any desktop applications. I do have a third-party Android application that I also subscribe with. But this is what the official thing looked like when he made the website 3 months ago.
What's the Ruby and JavaScript?
Ruby and JavaScript. There we go. Probably Rails on the back end.
And then comes up on
no further questions. I will yield the floor to the final speaker.
Welcome back.
Can you post that info on TriLUG?
Sure. What do you want me to post?
Well, if you want people to join, you probably want to say this is, you know.
Yeah, that's on there on the blurb.
We got something.
My name's Dusty. I'm going to talk about MiniShift. I'll actually go through that again. This is a lightning talk, so I'll start with who. My name's Dusty. I work for Red Hat. I'm an engineer. That's all you need to know. Really, we're here to talk more about you. We're going to talk about OpenShift Origin. If you don't know what that is, I can let you know. But why? Because Kubernetes is cool, maybe. Depends on who you are. At least the industry would like us to think so, right? Where? Your laptop. We're going to try to run it on your laptop. And how? A project called MiniShift that some of the people behind OpenShift Origin are basically trying to get it out to people who are running, on Windows, on Mac, on Linux, and just want to spin it up in an environment on their laptop. They don't necessarily want to, post it on a server or put it in the cloud. The project website is github.com/minishift/minishift. So pretty easy to remember. So let me go to that website. Yes. Freestyle tabs is an enabler. It does not make less tabs. It just means I can have more. Anyway, so the project is called MiniShift. They have pretty good documentation. You see right here, welcome to MiniShift, and then get started. You click on get started. You'll go to the documentation section, and you'll click on getting started with MiniShift, and you go to a nice docs website. And the next step is installing MiniShift. And depending on what operating system you are on, Mac, Linux, Windows, it kind of has it broken down. Some of them you don't need to install anything extra. It just so happens I'm on Linux with KVM, so I need to install a driver for that. And it actually goes through and gives you a few commands to run. There is a Docker machine KVM project that you need to install in order to run it. It is not in an RPM right now, or a dev. Well, it might be in a dev. I'm not sure about that. It's not in an RPM. So the steps that they've given here are essentially to download and install the binary. If you look over in a different terminal that I ran earlier, you can see I actually ran these exact steps. So I basically downloaded from GitHub. Do I need to make that bigger? I don't know if I can make it bigger and also legible. So I downloaded from GitHub and wrote it out to the user local bin Docker machine driver KVM file, and then I also made that executable. So I'm following the exact steps from the project website. So those are these two steps. At that point, if you need to install libvirt, you can. I already have it installed, so I don't need to do that. If you're on Linux, you probably do. The next step is just to install MiniShift itself. It's another binary. You basically go through to the MiniShift release page. Latest release is 1.8.0. Go down here, and there is a tarball with Linux 8.64. So let's switch back over to my place where I did this before. So I just basically ran a wget, grabbed the tarball. It redirected me to Amazon AWS S3, obviously, and it downloaded it into a tar.js tar.gz file. So here's the tar.gz file. I extracted it, changed directory. We have a mini-shift binary there. And I then aliased it to the full path. I could have put it in user local bin, but I just decided not to at this point. So now we have mini-shift on our machine. I ran mini-shift -- version, which is not an actual thing you can do, so I got the help command. And then I realized it's actually a subcommand instead of an actual -- option. So I ran mini-shift version. And then I can run mini-shift status. And if we go back and we look at the documentation, and we go back one step further, we can go do the mini-shift quick start. The mini-shift quick start basically says run mini-shift start, which is pretty simple. So I ran mini-shift start. So basically what it does is it brings up a small VM. It's got, this VM has 2 gigabytes of memory, 2 vCPUs, and 28 gigabytes of disk space. You can configure that. That just happens to be reasonable defaults. And it also happens to download OpenShift and run it in a container within that VM. And what it does is it will tell you, hey, this server is accessible via the web console and you can right-click and bring that up in your web browser. You can also log into it with this username and any password that you want to. And then it also tells you how to log in as an administrator. So since I did that at home earlier, I actually did stop the machine and I did start it again. And you can see if you do that, it basically doesn't re-download everything, it just starts it up. But what we will do is actually open this in our web browser, and hopefully it will work today. Or not. Let's check it. Mini-shift status. Stopped. And it says something about this usage. Okay. Let's see if it works this time. I let it run for a little while, so it wasn't happening.
I've never had a live
No, not at all.
Not today, anyway.
Yeah. Well, you didn't have any AVs.
That's right. Yeah, I already had my AV design.
This was supposed to happen, everybody. This gives me an opportunity to take any questions. Does anybody have any questions?
Oh, is this based on the newer OpenShift or the older one?
The newer one. So basically, you get Kubernetes. With, it's a little more stable than upstream Kubernetes, just because it's baked longer. And there's some things on top that have not yet been accepted back upstream. But they're working to get those accepted back upstream. So let's see if we can actually access it now. Yes, we can. Okay, so basically, I had already logged in previously, but if I log back out and return to the console, I'm developer, and I can essentially type in whatever I want to and log in. And you can pretty much do whatever you want to, create a new project. Let's see, I can go into this project, browse catalog, add a new Perl application because we all love Perl, and just go with it. Actually, let me not do a persistent one. How do all these say persistent? Oh well. We'll go with that. So I made a new Ruby application, and now it's kind of spinning up these. It's got a Postgres container as well as a Rails application that's going to run on top of it. So that's essentially OpenShift on your laptop. Download 2 binaries, run it, check it out, see what you think. Any questions?
And your Docker machine driver at KVM is open source?
Yes. Yes, on
But
GitHub.
just now I check the Docker machine community. I don't find the Docker machine driver for KVM.
It's if you go to the meeting.
You didn't sub your driver into the Docker machine.
I didn't understand the question.
Okay, I mean you didn't provide your Docker machine driver for KVM into Docker machine community.
No, so I didn't actually write the driver. It's on GitHub, and I will show you where that is real quick. It's basically just a plugin because the whole architecture is pretty pluggable. And a lot of people use the Docker Machine KVM plugin driver. So installing Minishift, if we go down to setting up the driver plugin and you look, where we download it from is actually from this GitHub project. And this is the GitHub project for the Docker Machine KVM driver. It's DHILTGEN / Docker Machine KVM. So, yep.
Okay, you maintain the KVM driver by yourself, right?
No. This is just a project. I actually don't maintain Minishift at all. I just thought I would show it off. A team that I used to work in does. So,
okay.
Yeah. Yes.
This is different from OpenShift Origin, which you can install on your laptop, right?
You can install OpenShift Origin on your laptop if you want to.
I think there's an OC command.
OC cluster up.
Yeah.
So this is just a little bit different because OC cluster up will try to use Docker that is installed. Like if I have a Docker installed on my laptop, which I actually don't, it will use the Docker that's installed on your laptop. It won't use virtualization at all, right? What's nice about this is because it uses virtualization, it works on Windows, Linux, Mac, Debian, Ubuntu, Linux Mint, Arch, whatever you want to use. So it's a good layer of trying to solve all the problems, right? And it has different drivers. So it uses different virtualization drivers. So on Mac, it can use Xhive, VirtualBox, VMware Fusion, Linux, KVM, the VirtualBox, Windows, Hyper-V or VirtualBox. So it'll use any of those. Yeah. So it uses virtualization. OC cluster up, it basically just uses containers. Minishift also has some neat command line switches that enable you to automatically add persistent volume support and stuff like that, which is nice to be able to test. I did the Minishift -dash version earlier, but that showed help. So there's a lot of different helper commands that you can use that help you interface with things and set up things. So it's a convenience tool more or less. Any other questions? Cool. Thank you.
Just I think I have your adapter up here.
Oh.
I'm borrowing this.
No worries. Track you down.
Alright, I have a quick lightning talk here. So I'm Michael. I work on the same floor as Dusty, even though I'm the same stuff. We bump into each other occasionally. Showing off my IRC client. I spend a tremendous amount of every day on IRC, and I couldn't do my job without it. And having a nice client is important to me. IRC is an old protocol. It's not very good in a lot of ways. There's all kinds of problems I found and things that aren't very user-friendly about it. It doesn't recognize disconnects very well. Trying to maintain one session from one device to another, or deal with my device being off and running an IRC bouncer service somewhere that I connect to and disconnect. It's always kind of a pain. Finding a client that you like can be tedious. So I found this one, and it's really wonderful. It's a very simple web client. It's called The Lounge. It's a fork of something else that doesn't exist anymore, except in people's memories. It's really easy to use. Of course, it's open source. It's a Node app. And here's my instance of it. So it lost its connection while my computer was off, so we'll just reconnect here. I'm in the TriLUG IRC channel on Freenode, by the way. That exists. So come join 56 other people and talk about sometimes Linux stuff. Hey, there, yeah, somebody's saying something. So here it is. I mean, it's just very simple. All the channels on the left, the text, there's reasonable default for highlighting text in the right ways. No notifications are seamless. So if somebody pings me directly, I'll get a little pop-up just like any other notification in iOS. It looks about the same on my phone, in my browser on my phone, so it's real convenient. I run this on a $5 a month Linode VPS, and that's great. I deployed it on CentOS with Ansible. If somebody pokes me, I will stop being lazy and actually share the Ansible roles that made that happen. That's it. If you're looking for an IRC client, something like this, highly recommend The Lounge. Any questions?
Kind of reminds me of Fossil. I used to use that.
Yeah, I looked at that sometime.
Fossil, it didn't have a web page thing. It was like an install client.
Yeah, it's more.
It's older.
Yeah, it's older. It's pre-web app craze, but still kind of the seamless, going for the seamless experience in this way.
Fossil does actually have a web interface available for it now. It's also a Node application that sits on the server next to the Fossil core and it serves like a web app. So.
Okay, cool. Actually, now I'm remembering you telling me about Fossil at some point when I was starting to search for something like this. Yeah, okay. So apparently Fossil does have a web interface.
I'm assuming if you lose connection and then you reconnect, it catches you up.
Oh yeah, it catches you up. Oh, yeah, so we can look at like. So I have 13 unread messages in this Pulp Dev channel. That's the thing I work on for a living, and so it shows me right here new messages. We've got the bar across here. Can't highlight that apparently. So yeah, makes it really easy to see what we missed. If somebody pings me directly, actually somebody wants to ping me in TriLUG, we can kind of see what that looks like.
Anyone?
Aaron, you still on?
Yeah.
Dusty?
What's the
Hey, Aaron. The notification popped up down here, so you won't see that, but yeah, there it is. It puts it in bright red, so it's easy to find. It just does all the things you'd expect.
Can you customize the white color scheme and stuff
You
like that?
can, yeah. There's other ones that come with it. There's other themes that come with it. You can also provide your own, real easy. I like the default, and there's all kinds of settings. There's themes.
Something the same Node.
Oh yeah.
What was that free gear service from Red Hat? Maybe we could run this on that.
Well, the free gear service has been sunset. But do you have a question? Or are you pinging me?
What language is it in?
No.
Does it take much processing?
Almost nothing. I mean, it sits around doing
Such
almost nothing.
But the IRC isn't that exciting.
Yeah, IRC is not. I mean, and that's what a lot of people do all around IRC anyway.
Run on Pilot?
You maybe could.
Is it multi-user or just single user?
It is multi-user. Yeah, it keeps logs. So there's log files somewhere I could go look at if I really wanted to. It keeps all the history. Keep going, load more.
So we've had on Pilot, on TriLUG server, we've had a guest account that you can log into off the web page, a guest web client, to try and help new people to get into the club.
this could help as well.
It's good. Alright, that's all I've got.
Thanks, everyone. Thank you for all the speakers tonight. And now, at this point, we're heading over to Bada Wings for a tradition called TriLUG. So we're just going over to snack and drink beer, and discuss whatever the hot topics are today. If you're not sure where it is, ask somebody else here. With a lot of us know where it is and point you in the right direction. So, other than that, thanks very much for coming. And Michael.
If anybody wanted to make a contribution to the Pizza Fund tonight but did not have cash, I have this Square Reader and I can swipe a card for any amount you would like to make for. No contribution is too small, so just come see me if you'd like to, and thank you.